Good morning everyone. My name is Saurabh Roy. Today we will discuss one of the important numerical based on delta to star conversion. So first we will see this numerical is given, calculate the equivalent star circuit. Okay. So this circuit is given which is mentioned. The resistance between terminal A and B is 15 ohm. Resistance between terminal A and C is 10 ohm and resistance between terminal B and C is 25 ohm. So we should convert it to equivalent star circuit. So we should find out the value of R1, R2 and R3. R1, R2 and R3 are the equivalent star circuit resistance value. Okay. So first we will see the R1. R1 is the resistance which one is connected to the point A. Okay. So if you will see the formula of calculating R1 resistance is R1 equal to R12 into R13 divided by R12 plus R13 plus R23. So easy to remember. See, if A resistance, how many resistance are connected? A point, 15 ohm and 10 ohm. So just multiply that 2 divided by total whole resistance. So R12 into R13. So 15 into 10 divided by 15 plus 10 plus 25. So we will get 15 into 10, 150. 15 plus 10 plus 25, 50. So 50 divided 150 divided by 50. So answer is 3 ohm. Okay. So similarly, if we will see the value of R2. So R2 is the resistance connected to the B point. The resistance connected to the B point. So how many resistance are connected in the delta network in the B point? 15 into 25. So similar, 15 into 25 divided by 15 plus 10 plus 25. That is the value of R2. Okay. So you can see there the value of R2 is R12 into R23 multiplied. R12 multiplied R23 divided by whole resistance R12, R13 and R23. So all three resistance, whenever we are calculating R1, R2 or R3, this lower terms is common for all cases. This is the addition of all three. So now we will multiply, calculate the value of R2. So R2 is 15 into 25 divided by 15 plus 10 plus 25. So we are getting the 15 into 25, 15 plus 10 plus 25. So that is 7.5. 15 into 25. Okay. So because R2 resistance we are calculating, and so whenever we are calculating the R2 resistance, we will find out the resistance which are connected to the P point. So how many resistance are connected? 15 into 20, 15 and 25 ohm. So we should multiply this 15 and 25 ohm divided by total resistance. So that is the value of R2. Similarly, we are calculating the value of R3. So R3 is R13 into R23 divided by R12 plus R13 plus R23. So 10 ohm into 25 ohm divided by 10 plus 15 plus 25. Okay. So we are getting the R3 resistance is 25 into 10 divided by 15 plus 10 plus 25. So 25 into 10, what is the answer? 250. Okay, divided by 50. So the answer is 5 ohm. So we are getting the answer is 3 ohm, 7.5 and 5 ohm. Okay. So that is the easy way to calculate equivalent delta to star circuit. Now we will see the another problem. So here the difference is, here resistance value are difference 9 ohm, 6 ohm and 5 ohm. So we should calculate its equivalent star circuit. Okay. So see, first we will find out the resistance of R1. So R1 means whenever we will find out the value of R1, so then R1 is 9 ohm multiplied with 6 ohm divided by 9 plus 6 plus 5. Okay. So see, R1 is R12 into R13 divided by R12 plus R13 plus R23. Okay. So we will see 9 into 6 divided by 9 plus 6 plus 5. So 9 into 6 is 54 divided by 20. Okay, so answer is 2.7. Similarly, we are calculating the value of R2. R2 is the resistance which is multiplied with 9 ohm and 5 ohm. The resistance which are connected with P point. So two resistance are connected. One is 9 ohm, another one is 5 ohm. So we'll multiply these two divided by total resistance. So this term is common for all three cases. So 5 into 9 divided by 9 plus 6 plus 5. Okay, 5 into 9 is 45 divided by 20. So the answer is 2.25 ohm. Clear? Now we'll move to the last one, that is R3. So R3 is R13 into R23. R13 is 6 ohm, R23 is 5 ohm. So 6 into 5 divided by 6 plus 5 plus 9. Okay, so divided by total resistance. So what is the value of R13? R13 is 6 ohm, R23 is 5 ohm divided by 12. So 6 into 5 divided by 9 plus 6 plus 5. So answer is 1.5. Okay, so this is the way we are calculating equivalent star circuit core, okay, from delta circuit. Okay, so thank you everyone.